A few days ago, I had students looking at Boyle's law. They used a setup like this one, where they added masses to the top of the syringe, and the more mass they added, the more the air in the syringe was compressed. But then I overheard a couple of the students discussing their results, and one of them asked, "So what was the weight that we put on?" No, no, no. Weight is not the same as mass. Are they related? Yes, but they're actually talking about different things. In much the same way as, let's say, someone coming to school and someone's favorite color are talking about different things. Grace, how did you come to school this morning?
By bus.
Okay, fair enough. Daniel, what's your favorite color?
Green.
Green. So you came by bus and favorite color green. Thanks, guys. Came by bus, favorite color green. Bus, green. Bus, green. Those two concepts are talking about different things. One's talking about how Grace came to school, the other one is talking about what is Daniel's favorite color. Different concepts. Now, in much the same way, mass is not equal to weight. They do not refer to the same thing. All right. This is a common misconception. These two words just get interchangeably used, like they are the same thing. They're not. Let's say you jump on the bathroom scales. Here you are. You're all happy. You jump on the bathroom scales in the morning. There it is. And the reading on the scales might say something like, let's call it 60 kilograms. There you go. Unfortunately, we say that you weigh 60 kilograms, but what that's referring to is actually your mass. You have a mass of 60 kilograms. Your weight is not 60 kilograms. The thing is, weight is actually a force, and as such, it's measured in newtons. So weight is a force, and therefore the units of weight are newtons. Right? Capital N for the Newton, whereas the unit for mass is the kilogram. So weight is a force. It's dependent on gravity. Weight is the force of gravity acting on an object. Now, what we could do is go to Newton's second law of motion, whereby if a force acts on a mass, the mass will accelerate. So in mathematical terms, F equals ma. That F is the weight force. Okay, so we could write weight force is equal to the mass times the acceleration due to gravity. All right, these things are essentially the same equation. In terms of weight, it's the weight force, and it's the acceleration due to gravity, so we could write that as a g. Now on Earth, gravity is about 9.81 newtons per kilogram. So every kilogram of mass has a force of 9.81 newtons pulling it down towards the center of the Earth. Let's just simplify things and call it 10. It's often taken as 10. I prefer to use 9.81. I don't think it's that tricky a number. But for now, let's just call it 10. So you jumped on the scale. Your mass was 60 kilogram. But what is your weight? Well, let's change color. Here we go. So 60 kilogram mass, but your weight is that mass times gravity. And like I say, let's just call this 10. It's 10ish. It's 9.81, but we'll call gravity 10 for now to make the maths super simple. And so your weight is now actually 600. Remember, it's measured in newtons. Weight is a force, so measured in newtons. So there you go. They're not the same thing. Your mass is 60 kilograms. Your weight is 600 newtons. Now, let's just assume you teleported to the moon. All right, so 1 second you're here, the next second there you are standing on the moon. I'm assuming you've got, an air tank. I don't want to kill you off or anything. So you're on the moon, and your mass, well, that's still 60 kilograms. But your weight, remember, was dependent on gravity. Now on the moon, gravity isn't 10ish, that's on Earth. On the moon, gravity is 1/6 of that. It's about 1.7 or so. Okay, so gravity on the moon is 1/6 of what it is on Earth, which means your weight on the moon is going to be 1/6 of that 600 newtons. So on the moon, your weight will be 100 newtons. Okay, your mass hasn't changed because you teleported there. All right, so you didn't have a chance to eat a big meal or go to the loo and suddenly have a bit less mass, right? Your mass was constant, But depending on the gravity where you are, your weight will change. If you went to the top of Jupiter, to the surface of the clouds of Jupiter, the gravity there is about 2.3, I think, maybe 2.4 times the gravity on Earth. So your weight would go up. Okay, remember, weight is your mass times the gravity wherever you are. Mass is how much matter goes into making up an object, so that doesn't change depending on location, but weight depends on gravity. So depending on the gravity of the different locations, your weight will change. So there you go, mass and weight, not the same thing.
Don't forget to hit the like button. Yeah. And subscribe too. It's up here. And here's another video.